Okay, so we've talked about the protons and neutrons, but we need to talk a little bit more about the electrons and how they're organized in the atom. So they're going to be put into these electron shells, and the first electron shell, the maximum number of electrons that can fit into the first electron shell will be 2. So for example, if we have like a carbon atom, which would have 6 protons and 6 neutrons in the nucleus, and because it has 6 protons, it's going to have an equal number of electrons as well, so it would have 6 electrons. So in the first electron shell, we would put 2 of the 6 electrons. Okay, so the maximum number of electrons that you can put into the first electron shell would only be 2 electrons. And I think of the maximum of 2, like you only have 1 bedroom and you can only fit 2 kids into that bedroom. Okay, and once you've got the 2 kids in the bedroom, 2 electrons there, it's full. Okay. All right, so the second electron shell, because we still have 4 more electrons to go, the maximum number of electrons in the second electron shell or third electron shell and up, the maximum number of electrons that you can fit would be 8 electrons. Okay, so this would be good to remember. And so what we'll do is we'll put 1 electron into each of our bedrooms here. So there's going to be 4 bedrooms in this second electron shell, and each one we're going to put an electron in. Now this second electron shell we haven't filled up, so there could be more electrons that we could put in there, but for carbon it only has 6 electrons, and that's what it has here. But if we have something like oxygen, for example, or actually let's do neon. So neon has 10 protons and 10 neutrons, and then it has 10 electrons because the protons and neutrons are going to be equal. So in our first shell, we'll put 2 electrons. And then in our second shell, we've got 8 more electrons. So we've got 2, and then we've got 8 left. So what we do is we put a kid or an electron in each of the 4 bedrooms, and then they've got to start sharing. So then we put 2 electrons or 2 kids in each of the 4 bedrooms, and now the 4 bedrooms are all filled up. So we've got our 8 maximum here in our second shell. And then if we had more electrons to go, then we would draw our third electron shell, and you could keep going after that if you had even more electrons. Okay, so but just remember 2 maximum electrons in the first shell and then 8 electrons maximum in the second shell and on up. Okay, and then this is just what we drew. This way of drawing the electrons like that and these electron shells with these rings like this is just called the Bohr model. It's just named after a chemist who came up with this way of drawing the atoms like that, and his last name was Bohr. So, okay, the outermost electron shell is called the valence shell. So, like in this picture here, here's our nucleus, and then here's our first electron shell, and then here's our second electron shell. So this outermost electron shell, this would be called our valence shell. Okay, and the electrons that are in the valence shell are called the valence electrons. Okay, so why do we care about the valence shell and the valence electrons? Well, the chemical behavior of an atom is actually determined by the number of valence electrons. So if that valence shell is not full, so like if you don't have, that magic number of 8 electrons, like in that second shell, then the atom's going to either lose, gain, or share electrons to fill it up. Because the whole goal of the atom is it wants a full outer valence shell. And so chemical bonds are going to be formed between the atoms when electrons are lost, gained, or shared. And so these atoms are going to be chemically reactive. Okay, so atoms that do have a full valence shell are not going to react very easily with other atoms. And so these are called noble gases because they're, like the kings and queens, and they're not going to react with, the common elements, the people below them. So, for example, we have this neon atom, and you can see the first electron shell here. And then here's our valence shell on the outside. And you can see it's got 2, 4, 6, 8 electrons. So that outer second shell is full. And so neon is very happy by itself, and it says, I don't need to share electrons with anybody. I don't want to give any away. I don't want to gain any electrons because I've got a full valence shell. I've got the magic number 8 in that second shell. So neon is not going to react with any other atoms and form chemical bonds with them. So it is happy by itself. So if we look at our periodic table and we look at this group, this column going down on the very far right of your periodic table, these elements in this group going down, these are called noble gases. So they are not going to react with other elements at all and form chemical bonds. So you can see like helium has a full shell. It has that magic number of 2 in the first shell. Neon has a full valence shell. It has 8 in that second outer shell. Argon also has that magic number 8 in that third valence outer shell. And so they're not going to react and form chemical bonds with the other elements. Okay, and then this is just kind of a nice summary of what we've been talking about so far. So the protons with their positive charge in the nucleus, they are going to give us the atomic number, and they're going to determine the element, which element it is. The neutrons in the nucleus have no charge, and they're going to determine which isotope it is because the number of neutrons can change in the nucleus, and that'll determine which isotope you have, like carbon-12, carbon-14. And then the valence electrons, the ones in the outermost shell, they're going to determine the chemical behavior of that atom. So how many bonds they're going to form, or maybe they don't form any bonds because they have a full shell.